up like I've been doing. So we haven't talked about the idea with the horizontal stretch and shrink. We've talked about vertical stretch and shrink. So horizontal goes like this. The basic idea, we're going to go ahead and graph this function and just kind of discover how this works. Okay, so the first thing we're going to do is your elementary function's y equals x squared. Okay, so you want to go ahead and just fill this out. You square these numbers in your head, so that would be 4, 1, 0, 1, and 4. And then you want to go ahead and plot those. And then we're going to see what happens when we put that 2x inside the squaring. Okay, so go ahead and plot those points. This will be your elementary function. Okay, and then we want to just get that labeled. I'm just going to do that in a dashed line, and we'll say that's y equals x squared. That's our elementary function. And what we're going to do on this, just to kind of show you what happens, is we're just going to crunch these things out one by one. Thank you. Okay, so let's go ahead. I'm going to go at the side, and I'm just going to plug these in like this. So the first thing we got is we're graphing y equals 2x to the second. Let's just one by one plug these in and just see what happens. Okay, so if you replace x with 2, you're going to have 2 times negative 2 to the second. So that's going to be negative 4 to the second. So that's going to be equal to 16. Okay, so something's happening on that problem. It's getting transformed. We won't know how this works until we finish all these up. Now go to the next one, go to negative 1. So you're going to want to go y equals 2 times negative 1 squared. So that's going to be negative 2 squared. So that's going to be equal to 4. So that new point right there is going to be 4. Okay, then we go to 0. So again, go to the function we're graphing. You'll do y equals 2 times 0 squared. That's 0 squared. So that's still equal to 0 like that. Okay, now if you continue to do this, these are going to be the same. Okay, I mean, if you went through and if you plugged in now 1, 2 times 1 squared is going to be 4. And then if you plug in the 2, you would have 2 times 2 squared. That would be 4 squared, so that's 16. So I'm doing the arithmetic on that. Does everybody understand what I just did? Okay. Now go ahead and plot these points, and then we'll kind of talk about what happened on this. So I'll pick a different color, and I've got negative 2, 16. That's way up there, so I'm not even going to bother plotting that. So it's just way up there. Then you got negative 1, 4 is there. You still got 0, 0. You got 1, 4. So in other words, if you just take like those points right there, okay, well, look what's happened on this. Okay, there's two things that have happened. If you're thinking about it vertically, you're stretching it vertically, but how about if we do it this way? Then it's shrinking this way. So we call this a horizontal shrink or a horizontal compression. Those two words are interchangeable. So what I want you to say on this is just write somewhere that this is a horizontal shrink, or let's use compression. I think that's what our textbook does, is compression. Horizontal compression by a factor of 2. Okay, and what it has to do with is the size of that number. Since that number is bigger than 1, that's what causes it to compress. So that number, if that's bigger than 1, it causes that. You don't have to memorize that. You can figure that out just by doing some number crunching. Okay? All right, what is the domain of this thing? That's all real numbers. You got a quadratic, that's all real numbers. The range on this, what is the lowest value of y in the graph we just did? 0, right? And we include 0, and then you go to infinity like that. Okay, so that would be how that works. Okay? We're going to do the second problem the same way, but I want you to think about the second problem. It's got a half x. What does an absolute value look like? It looks like a v, right? So what do you think the half's going to do? It's going to stretch it this way, horizontally stretch. Okay, let's crunch it out, and let's make sure that we can do that okay. All right? So we're going to do the elementary functions, the absolute value of x. You just do the absolute value of each one of these numbers. Okay, like that. And let's plot those out. So we have negative 2, 2, negative 1, 1, 0, 0, 1, 1, and 2, 2. So you want to go ahead and get those things plotted. Okay, then what we're going to do is we're just going to number crunch the same way we did the next one. This is a mistake. I think that's supposed to be 1/2 x. That was the intention. So if you'll just mark that off and make that 1/2 x. Okay, so let's just number crunch and see what happens. Let's start with -2. So we would have y equals absolute value 1/2 times -2. Okay, see the 2's cross out. That really gives you absolute value of -1. So that gives 1. Okay, right? And while we're at it, we'll just plot these points. So we have the point -2, 1. That just means that thing, you can see that this thing's kind of stretching like this. So that's your first point. Okay, plug in the -1. So now you would have y equals absolute value of 1/2 times -1. Okay, that's absolute value of -1/2. So that's equal to 1/2. Okay, you can use 0.5 or just use 1/2 like that. Does that make sense to everybody what I'm doing? Okay, just doing some arithmetic. So if you plot the point -1, 1/2, then you can see how that thing's kind of flattening out like that. So you have that point there. Okay, now if you do the same arithmetic, we'll do one more, and these things are symmetrical. So if you go to 0, you would have y equals 1/2 times 0. So you'd have absolute value of 0. So that's still 0. Okay, so what would happen then is your points are going to kind of go up kind of like that. And if you did the same number crunching here, you would get 1/2 there and 1 there. And then if you plotted those points, you would end up having a graph that kind of goes like that. Okay, so I want you to see how the arithmetic goes, and then you want to be able to recognize how that affects the graph. So what we would say on this, and you can name this two ways. You could say this is a vertical shrink because you can think of the V being flattened out, or you can think of it as a horizontal stretch because you can think of the absolute value being stretched this way. So we're going to call this, let's just label this a horizontal stretch by a factor of 1/2. Okay, that's how that goes. So what I want you to see on this is basically this. All right, here's what you as a student want to learn. Okay, if you're multiplying the x inside the function by a number, that affects things this way. Okay, if that number is bigger than 2, what it does is it compresses it this way. If that number is between 0 and 1, what does that do? It stretches it this way. Okay, you don't have to necessarily memorize that because you can always figure these things out by number crunching, right? Okay, so it boils down to doing some arithmetic, and then you can get those things worked out. Does that make sense to everybody? Okay, all right. So the domain on this one, again, is all real numbers. The range on this is just like the last one. The lowest value of y is 0. The y's get bigger infinitely, so we would say bracket 0, infinity like that. Okay, so that's called a horizontal stretch or compression. One thing that I want you to kind of notice on this too is this is what we talked about last week. Okay, if you had something like this, okay, if it's outside, if that number is outside of the operation, then what it does is it vertically stretches and shrinks. And you don't want to memorize this, you want to understand this. See, if I put a 2 there, all you're doing is multiplying the y values by 2. That makes the y values get bigger, so it stretches this way. This one makes the y values get smaller, so if y values get smaller, doesn't it flatten? The y values get smaller. So you've got to think about if that number is outside, then it's a vertical stretch or shrink. And these things are opposite of each other. This one would be a vertical stretch. That would be a vertical shrink. Notice that they're opposites of each other. Okay, so that's kind of a good connection to make on that. Does anybody have a question about that and how that works? Okay, all right. Yeah, and you want to crunch out the arithmetic when you're doing this. Okay, now what we're going to do is we're going to try to put this all together on this next page. And when we get into our second exam, you'll do a lot of problems like this without your calculator. And there's a real important order to the way you do these problems too. Okay, so I'm going to take you through what that order is. So I would like you to rewrite this problem we're going to do as -2 x minus 3 to the second plus 4. I just think you'll see it better that way. Now here's something that you want to make sure that you understand is you've got to do this in a certain order. Okay, the first thing you always do is you work inside parentheses. You're following order of operations. So what you always do first is you always do any left-right transformations. Remember, we've talked about that the x minus 3 is shifting everything to the right 3. That's where you want to start. The second thing you always want to do is that multiplication. And you can do this all in one step. You just multiply y by negative 2. And then the last thing you always do is this thing. Okay, you do the up-down stuff like this. Now, you don't have to memorize this because I want you to think about order of operations. Like if you plugged a number in for x, say that you plugged in 4. Wouldn't you do what's in the parentheses first by order of operation? Yeah, then you would do the operation of squaring, then you would multiply, then you would add. So when you're doing these transformations, you're actually following the order of operations. And if you do those out of order, you're not going to end up with the right graph. So always start this way, then go there, and go there. That's always the last thing you should do is do the up-down stuff. Okay? So what I'm going to show you on this one is a couple of ways to do this, and you can kind of decide which way you want to do this first. The first thing we're going to do is we're going to graph the elementary function. The elementary function is y equals x squared. We're doing a squaring function, and then we're going to do all the transformations, okay? So you can make a table of values if you need to. So what I'm going to do is just use, these numbers. You don't necessarily have to write this table down. So what we're doing is just squaring those numbers. So we'd have negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4 like that. And then what I want you to do is just plot those points. Okay, so let's go ahead and just get these points plotted. And we're going to transform these 5 points to their new location. So I'm going to show you 2 ways to do this. Okay, so the first thing I'm going to do is I'm going to teach you how to do just kind of a sequence down at the bottom of the page. Okay, sometimes students do it better this way. That's the reason I'm going to show you how to do it that way. So I'm just taking these points. I've already typed those out. I think one of them's wrong. I think this last one is the 0.24. So I typed that wrong. Okay, so I'm going to show you how to do it this way. Okay, this way, if you want to do it this way, like on tests and homework, then do it this way. All right, what is the first thing I said you must do? Left or right, exactly. So what we're going to do is on this particular problem, let's see, what we're graphing is we're graphing negative 2, x minus 3 squared plus 4. Okay, look at that part right there, x minus 3. Is that right or left? Right. It's right. Okay, remember we've already talked about that. If that was a plus 3, everything would go to the left. So what I want you to put in your table is let's put right 3. Okay, and then just kind of draw like a diagonal like that. Well, what you're going to do on this is you're just going to make these x values get bigger by 3. And you don't have to write all this down. I'm just doing negative 2 plus 3 is 1, and then the y value stays the same. Okay, same thing with this. This is an x value of negative 1. Negative 1 plus 3 goes to 2. Y stays the same. You're not changing y, you're changing x. You're moving everything to the right 3. Okay, this one, you take x is 0. 0 plus 3 is 3. So that moves to 3, 0. Okay, then the next one, 1 plus 3 on the x would take you to 4, 1. And then finally the last one, 2 plus 3 on the x would take you to 5, 4. Okay, like that. So this is if you learn the order that these things are done in, you can easily do this. So what I want to show you is it's the x's that changed while y stayed the same, right? Okay, everybody with me there? So I just made all the x's get bigger by 3. That's what moves them to the right. Okay, what is the second thing I said to do? Multiply the y's by negative 2. That will reflect and stretch at the same time. You don't have to do them separately. So what we're going to do next is we're going to do this. Just write it this way. Multiply y by negative 2. I prefer students write it that way because they understand it better than if you just say reflect and stretch, because it's going to do both at the same time. So what you do now is the x's are set. Just bring those x's down. Don't change those. Just bring them down like that. Okay? Now what I'm going to do, and you're going to do this in your head, what you need to do is just take all of these y values that I'm highlighting in blue and multiply them by negative 2. Okay, when you do that, you'll have your next place then. So 4 times negative 2 is what? Negative 8. Okay. 1 times negative 2 is negative 2. 0 times negative 2 is still 0. 1 times negative 2 is negative 2. And then 4 times negative 2 is negative 8. You guys see what I just did? So I'm following order of operations, okay? So what was the last thing I said to do on this problem?
Up and down.
Yeah, up, down. So what are we doing? If it's plus 4, what is that? That's up 4. So what that's going to do is when you go up 4, the y values just need to have a 4 added to them. So the x's are done, see? So you just bring those x's down, and then you just do this in your head. I'm going to write this out. Negative 8 plus 4, that's going to be at negative 4 now. Okay, the next y value is negative 2. Negative 2 plus 4 is 2. And then I do 0 plus 4 is 4. And then again, negative 2 plus 4 is going to be 2. And then finally, negative 8 plus 4 is equal to negative 4. So these are your final points. If you plot those, that will tell you where the graph is transformed to. Okay? This is just one way to do it. I like to teach it this way because a lot of times students try to do it all in the graph, which you can learn to do. To me, it's just as easy to formalize it this way. So now you're doing the arithmetic and you know how the arithmetic goes. So what I want you to do now is just plot these 5 points right here, and then we'll have what the new graph looks like. Okay, so we just go 1, negative 4 would be the first point. Then we have 2, 2. Then we have 3, 4. And 4, 2. And then finally 5, negative 4. And then if you connect those dots like that, that's what that graph looks like. Now what I want you to look at is I want you to see if you can see all these transformations in this problem. Okay, so does it look like look at this point right here. Did that move over to the right 3? Yeah, okay. Did everything reflect? Yeah, you can tell that. Does it look like it's skinnier? It actually is. It's hard to see, but this thing has been stretched vertically, and then everything's been moved up 4 like that. So if you look at everything in there, you can tell every point has been moved to the right 3. It's been moved up 4. It's turned upside down, and then it's stretched. Okay, does that make sense to everybody? Okay, so if you do it this way, in a sense, you're just changing this into an arithmetic problem. Okay, you're making it simple. Now, I don't care that you do those points that way. Like on a test, some students like doing it that way. Some students just like going to the diagram and trying to process it all in their head. It's up to you. I'd recommend you do it that way because you're probably more likely to get it right. That's the reason I teach it that way. Does that make sense to everybody? Okay. All right. So let's move to the next thing. We're going to kind of redo this with several things, and this is kind of what you're going to get into in this section. So with this one, same thing. We're going to graph y equals x to the second first. So I've already got the points on here, except that should have been a 2, 4. So these are the same points. So you want to go ahead and just start by plotting out your points on the x squared. So you've got negative 2, 4, negative 1, 1, 0, 0, 1, 1, and then 2, 4 like that. Okay, and that'll be our elementary function. And we'll try to put this together. So what do we have? We have y equals x plus 1 squared minus 3. Okay, so let's see if we're on top of our transformations. Tell me what the x plus 1 does.
Is it left 1?
Left 1, good. Okay, so that's left 1. Okay, tell me what the minus 3 does.
Down 3.
Okay, good, down 3. Okay, which order do you do those in? You do the left, right first, and you always finish with up, down. If there was a stretch or shrink in the middle of that, you do that kind of in the middle. So what I'm going to do is this. Now, you could do this one pretty easily without the graph, but I'm just going to go ahead and keep doing these the same way. We're going to start by doing left 1, then we're going to move to down 3. You can actually do these at the same time because it won't make any difference. So what I'm going to do on this first one is the y values stay the same on the first step, because if we move something to the left, it's the x values that change, not the y values. Okay, just do this in your head. If you do -2 minus 1, that moves to -3. If you do -1 minus 1, that goes to -2. 0 minus 1 is -1. 1 minus 1 is 0. And then 2 minus 1 is 1. So what did I do? I just made all of those x values go down by 1. All right, I moved it left 1. That's what you're doing, is you're subtracting that. Okay, everybody with me there? Okay, now down 3, what do I change, x or y?
Y.
I change y. So see, the x's are set. So when you go to this next step, don't do anything with x, just leave it alone. And then take all of those y values and make them go down 3. Okay, and you can do this in your head. Just take the y values. So 4 minus 3 is 1. 1 minus 3 is -2. 0 minus 3 is -3. 1 minus 3 is -2. And then 4 minus 3 is 1, like that. Okay, so by doing that, you should have a new set of points that if you plot, should show these transformations. So what you want to do next is just plot that set of points and see what it looks like. Okay, so it looks like we got -3, 1. We have -2, -2. -1, -3. 0, -2, and then we have 1, 1. So that would be what your final product looks like. So can you see on there that all we did was just move left 1 and down 3? Okay, every point did that. That problem right there is easy enough to do without doing that table, because all you're doing is taking every point left and then down in that order. Okay, like that. Okay? All right, everybody okay? Okay? So see, when you're doing these problems, a lot of times students, I can tell, don't do this right, but you can tell you're right just by crunching out arithmetic on these things. But I want you to know the order the transformations go in. Okay? Okay, any questions about that? Okay, I'm going to do just a few more of these to kind of get the idea, and then there's a second part of this to kind of summarize this. Okay, with this problem, okay, we're now doing an absolute value. What does the absolute value look like? That's the V looking thing, okay? Let's just go ahead and crunch it out. You don't have to write this table of values, but if you need to figure it out, then this is what you're always going to do. So I'm just doing the absolute value of each number, okay, like that. Now see, I've already got these basic numbers here, so what you need to do is just fill out these numbers. That would be a 2, a 1, a 0, a 1, and a 2. Okay, so those are the elementary points. So you want to go ahead and plot that first list of points that's in my table of values. So I want to get that done. And then that will be your basic elementary function. Just kind of lightly dash that in like that. Okay, so let's see what we're doing here. It looks like the graph we're doing is y equals -2 x plus 4. Okay, so let's talk about what the transformations are. What does that plus 4 do? About 4. What does the -2 do? It multiplies the y's by -2. So it's going to do two things. What's the negative going to do?
Flip it.
Flip it. What's the 2 going to do? It's going to make the y's get higher, so it's stretching. See, what that's going to do is make all the y's get bigger, therefore they get higher, so they stretch. So the transformations, you want to just write these transformations like this. What we have is we have up 4, and then you could also just write multiply y by -2, but you really want to write that as you just want to say reflect over x. You do want to tell me which axis it's reflecting over, so it's reflecting over x-axis, and then it's doing a vertical stretch. Okay, because you do want to be able to identify those transformations, so it's a vertical stretch. Okay, now you have to do this in the right order. You can't just go up and then reflect in whatever order you want to. If you have trouble remembering, just think of order of operations. Like if you put a number in for x, like 0, what's the first thing you would do? You would multiply, then you would add, right? Order of operations is going to say take this, times that, and add. So you're going to do really two things. what you want to do on your chart down here is you want to do this, okay? You have to start by multiplying y by -2, and that's going to reflect and stretch force at the same time. Then you want to finish by going up 4, like that, okay? So I'll zoom on this a little bit so you can see this a little better, okay? All right, so what we want to do in the first step, do the x's change in the first step, yes or no? No, it's just the y's, okay, because we're multiplying y's. So what I'm going to do is just bring those x's down. They aren't going to change. Okay, and then what you're going to do, you just, in your head, what you're going to do is take all of these y values, they're going to multiply them by -2. That's what's going to cause this thing to stretch and reflect. So 2 times -2 is -4, 1 times -2 is -2, 0 times -2 is still 0, 1 times -2 is -2, and 2 times -2 is -4. Does everybody understand that? Okay, what's next? Make it go up 4. So if you make it go up 4, what changes, x or y? Y. Good. So see what's going to happen on this problem is the x's are never going to change. It's only the y's that are going to change. So the rest of this you just kind of do in your head if you want to. You do -4 plus 4 would be 0. And I'm taking the y value and I'm just making it go up 4. -2 plus 4 is 2. 0 plus 4 is 4. -2 plus 4 is 2. And then finally -4 plus 4 is 0, like that. Okay, so what I did is I multiplied the y's by -2, then I moved them up 4. Okay, so now if you plot those points, you should see exactly what we're expecting to see. So just plot these 5 points, and then that'll give you the final product. So that's going to be -2, 0 is a point, -1, 2 is a point, 0, 4 is a point, 1, 2 is a point, and 2, 0 is a point. So that would be what your final graph looks like, is those 5 points have translated like that. You can see it's reflected, okay? It's a little harder to see that it's stretched, but it has, and then everything is moved up 4, okay? Everybody with me there? Okay, all right, so if you can do these in the right order and just realize that what you're doing is arithmetic, then they're not that hard to do, okay? Now this one, as far as the domain and range, the domain's going to be all real numbers. Now look at the range. Look at the graph in green. That's going from -infinity to where? To 4. So you would say -infinity to 4 would be how you write the range. And then you would put a bracket on the 4 like that. So I want you to usually kind of know what the domain and range is by observing your final graph. Okay? All right, any questions on that? Everybody okay with what I'm doing? Okay. So what I'm going to do next here, I want to do one more like this, and then we're going to kind of transition into to the second part of this handout. So this one is a square root. Okay, I'm going to go ahead and start by doing a table of values. So if you're doing a square root, I need to get this thing plugged in. What kind of numbers are you going to use for x? If you're doing a square root, what kind of numbers do you have to use? Okay, and what's the smallest number you would use?
0.
0, okay, because you know the square root of 0 is 0. So you'd want to just use the numbers 0, and then 1, 4, and 9. Those are just numbers that have perfect squares then. Get this plugged in so this battery doesn't run out on me here. Okay. Okay, so, and I've already got, these x values down there. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. Okay, so just fill these numbers in. You got 0, 1, 2, 3. Don't use anything that has a decimal, just keep it real simple. Okay, all right, so let's go ahead and let's plot those 4 points as our elementary functions. So we're going to have 0, 0, 1, 1, 4, 2, and then 9, 3. And we've already learned that. We learned that last week. That's what the graph of y equals square root of x looks like. Okay. Now let me write down what we're doing on here. We got y equals 1/2 square root of x minus 2 plus 3. Now let's figure out what the transformations are. Okay. And we're going to do this in the right order. So what is the x minus 2? What does that do?
Moves it over.
Right 2. Okay, so one of our transformations is right 2. Okay, how about the 3, the plus 3? What does that do? Up 3, because it's outside. It's changing the y value. So that's going to take you up 3. Okay, how about the 1/2? What does that do? You're multiplying. You want to think of it as multiply y values by 1/2. Now tell me what happens. If you take the y values and multiply them by 1/2, they're going to get smaller, right? So what's going to happen to that swoosh? It's going to flatten, right? Okay, don't memorize this stuff, understand it. The y's get smaller, therefore they flatten. So that's going to be what we call a vertical shrink. Okay, that's because of the value of that's making the y values go like that. So I'm just going to say multiply by 1/2. And it's good to write it that way, but like on your homework and stuff, if you're asked for your the translations, you want to write that it's a vertical shrink. And you say it's a vertical shrink by a factor of 1/2. That's how you do that, okay? Now, what order do we do this in? This is where students mess up. What do you have to do first? Right? Then what? Multiply by 1/2, then what?
Up 3.
Okay, all you're doing is following order of operations. You got to do what's under the radical, then multiply, then add. That is simply following order of operations. So if you forget, realize where it comes from. So when we do our chart, we're going to do this like this. The very first thing we're going to do is we're going to take all these points to the right 3. Then we're going to multiply all of the y's by 1/2. That's going to shrink it. And then finally at the end, we're going to bring everything up 3. So do it in that order when you do your points. Okay? What's that? Oh, right 2. Thank you. We go up 3, but right 2. Thank you. Okay, so what we're going to do is on your first, when you do right 2, does anything happen to the y's? No, it's just the x's. So what you want to do in step 1 here is just bring down the y's. They're not ready to change those yet. So just make all of the x's go to the right 2. 0 plus 2 is 2. 1 plus 2 is 3. You just do this in your head. 4 plus 2 is 6. And then 9 plus 2 is going to be 11. Okay, so that's going to move everything to the right 2. Okay, now we're going to multiply y by 1/2. Does anything happen to the x's in step 2? If you multiply y by 1/2, that means x is going to stay the way it is, right? So just bring these down. Don't change those. Now you're just going to multiply all of the y's by 1/2. So I'll write kind of what I'm doing here. If I do 0 times 1/2, that's still 0. If I do 1 times 1/2, that's 1/2. I'll just put 1/2. You could put a 0.5 there too if you wanted to. If I take the next one 2, if I take 2 times 1/2, that'll give me 1. There's taking half of that. And then if I take 3 times 1/2, that'll give 3/2, and 3/2 is like 1.5. So if you wanted to put a 1.5 there, I'm okay with that if you'd rather do it like that as a decimal. Okay, so we have that. All right, so now what I do is I move everything up 3. Is it the x's that change or the y's? It's the y's. Up 3 means you add 3 to all the y's, so the x's are set where they're going to end up. Okay, then what you want to do here is just all of these y values right here, just add 3 to them and just do it in your head. So 3 plus 0 is 3. 1/2 plus 3 is 3.5. I'll just write that as 3.5. Okay, if I do 1 plus 3, that's 4. And if I do 1.5 plus 3, that's going to be 4.5 like that. So those are your final 3 points that have been moved in the right order. Okay. All right, now if we go through and graph this, let's just graph these final 4 points here. Then what you would have is it looks like over 2, up 3. Then you would have over 3, up 3.5. So it's going to flatten a little bit. Then over 6, up 4. And then finally over 11, which would be over here, and up about 4.5. Okay, can you see that it flattened okay? Okay, so it did flatten by a factor of 1/2. And then you can pretty well see everything got moved over 2 and up 3. Okay, like that. Okay, so if you know the order you do these things in, you will be solid. Okay, that's the whole key to doing this. All right, does everybody feel okay with what I'm trying to show you? Okay, all right. You will do some of this in your written assignment. My math lab doesn't always do the greatest job on this because you have to kind of, sometimes the graphs are just picked by multiple choice. So you can, kind of when you're doing that, make sure you know how to do that chart and the right order that you move your points in. Okay? All right. So there's a second part of this. So let me load up this second part here. And this is more of a summary of what we did. So I think this is stapled onto your handout. Isn't that right? I think it is. So I think if you go on, I think you have this stuff right here. So all this is this is a summary of what we've learned on this then. So we're done mostly with our graphing. So what I want to look at on these problems is just seeing if you can identify what the transformations are. So on number 1, how many transformations are there? There are 2. What are they? Right 8, down 9. In that order too. Let's put them in the right order too while we're at it. So it would just be right 8. And then the second one, number 2, would be down 9 like that. Now we're not going to graph it or anything. I just want to make sure that you can identify the transformations okay. All right. Okay. How about number 2? We have negative x minus 9 squared plus 1. How many transformations are there?
3.
There are 3. What are they?
Right 9.
Right 9.
Invert x.
Invert x, okay. Reflect over the x-axis, reflect, and then up 1, okay? So if you did this in the right order, you would go to the right 9, like that. And see, that reflects, so you really want to write that as reflect, okay? So you're reflecting this way, okay, in the x direction. So I'll just have you put a reflect there, okay? And then you would have the third one would be up 1 like that, okay? And again, what that reflecting, it's not a bad idea to write down. All that's doing is it's just multiplying y by negative 1. That's why it reflects. It's all the y's get opposite, so that's what causes that, okay? All right. Okay, how about number 3? How many transformations do you see on number 3?
2.
There are 2. What are they?
Left 4.
Left 4.
Reflect over x-axis.
Good. Okay, left 4. That'd be your first one. And then the second one would be reflect over the x-axis. Okay, and again, what that's doing is that's really multiplying y by negative 1. It's a good idea to write that multiply y by that because that's really helps you remember and understand how that goes. Okay? All right. Number 4, how many transformations are on this problem?
3.
There are 3. Okay? First of all, what does the plus 1 do?
Up 1.
Up 1. What does the minus do?
Reflect over x-axis.
Reflect. What does the 8 do?
Stretch.
Okay, stretch. How do you know? Okay, because if you multiply the y's by 8, they get bigger. That's what I want to try to get you to understand, is the y's get bigger by a factor of 8, therefore it stretches it vertically. So that's going to be a vertical stretch by a factor of 8. So those are your 3 transformations. If you were doing this in the right order, well, the first thing you would really do if you were going to do the transformations the way I was teaching you is you would just multiply all of your y's by negative 8. That will stretch and reflect at the same time. There's no point in doing that in 2 steps. And then the second thing you do is you just move everything up 1. Okay, so that's how that goes. All right, everybody with me there? Okay, all right. So you do want to be able to look at a function and then know what its transformations are and the order that you do those things in. Okay, all right. So that's kind of where I wanted to start there, is just summarize those things, okay? All right. Next thing I want to do is we're just going to do a little matching thing here, okay? Some of these will be pretty easy. Some of them you got to do a little bit more, okay? I have an absolute value, right? So I think we could definitely rule out C. What do you think? Okay, what happened to my graph? How did it move?
It went right.
To the right.
Okay, it went to the right 3, so can you tell me which one would be the right one?
D.
D, right. Okay, this one would be going down 3. This one right here would be going left 3. Okay, so again, it's just trying to summarize what we've been working with, okay? Okay, the next one is a parabola, so it's based on x squared. Well, what happened to this thing? There's several things that happened to it. One thing it did is it turned upside down, right? Okay, so it did reflect. What else happened to it?
Stretch.
Okay, are you sure? I don't know. I'll have to look on this. This is a hard one to see. Okay, I may have to look at this carefully. Okay, well, let's see. How about the vertex? That vertex looked like it moved to the left 5 and then up 3. So I can see that pretty well. So let me show you how I know if it stretched or shrinks, kind of like this. So one thing that I would kind of see here is it basically kind of goes like this. If you look at your vertex right here, if there's not a stretch shrink, it goes like this. You go over 1 and then down 1. Or you go over 2, down 4. That's one way to look at it. It's like that. Okay? And then if you go over 3, it goes down 9. You know where I'm getting those numbers? They're squaring. Okay? So if you don't have a stretch shrink, it's over 1, down 1. Or start over again, over 2, down 4. I can't tell if that's right or not because I can't see very good. That's just one way to do that. So let's try to go over like 2 and then down 4 and see if it did that or not. So that looks like down like that and then down 4. That's clearly not working. So it looks like what happened on this one is you're going to have a number in front of that graph, okay, that's going to cause the stretch or shrink. Does that make sense? Okay, it doesn't follow that. Okay, now this is multiple choice, so you could reason this out. So let's see. We're going left 5, up 3, and reflecting, and then what's happening is that parabola basically is kind of widening out like this. So which one do you think it is?
A.
You think A? Okay, let's see. That's left 5. That's good. Okay, it definitely reflected, so that's good. Okay, we're up 3, so that's good. And then that half looks good. Okay, that's the number that's changing that, those Y values. What it's really doing is it's not stretching, it's compressing it vertically. So that should be the right answer. That's the hardest part of the problem, is figuring that out. Okay? All right, everybody okay? Okay? All right, now let's see if we can do these. Now this is just doing this backwards. This is just now I'm giving the transformations. Now you want to see if you can give me the equation on this then. Okay? So if I do this, let's see, we have y equals x squared. We're going to shift to the left and 3 downward. Okay. So how do we make this thing go to the left?
Add A.
Inside.
Okay, you would say add inside, that's important. So it would be x plus 8 to the second. And then how do you make it go 3 down? Minus 3 outside the function. That's good. I want to hear you say inside and outside because that's what it's, you got to know where those numbers are going. Okay? All right, let's look at the next one. You have absolute value of x, okay, and let's see, it looks like we're going to vertically stretch by 2, then we're going to reflect. Okay, so how do you make it reflect?
Minus
Put a minus there. How do you make it stretch?
2.
You put the 2 in front there. Okay, that's what causes the y's to change. So that's it. That's the only thing, only 2 transformations you have. Okay? All right, any questions about that? Okay, all right. So I think one last thing I want to look at here. Did somebody's great goodie work?
Yeah.
Okay, good. Usually it's the very first part of that's where a lot of times students go wrong. Okay, so let's do this last page here, and then we're going to start, or we have 2 more pages. What I want to look at. Okay, so this is one of the best ways to test, like on an exam, whether students understand how their transformations go. Okay, because this function is just a generic function. So what we're going to do is we're going to graph this on the same graph. So what this is saying is that 2, that's going to multiply all the y's by 2. So what I'm going to do is I'm just going to take some of these special points on here. I'm just going to pick some points, including like this one here and that one there. And then all we're going to do is we're going to make the y values multiply by 2. Okay? So it'll kind of go like this. So what I'm going to do is I'm just going to write these points out. So this first point over here is the point -5, 2. This point here is the point -2, 2. And then you have a point 0, 0. Then you have a point 2, -2. And then finally you have a point 5, -2 like that. Well, what's going to happen to the y values on this problem? They're going to double, right? Okay, so all you got to do is, so you don't have to write these points out because you can do this in your head, but that point is going to change to -5, 4. This point is going to change to -2, 4. Again, I'm doubling the y value. This one is 0, 0. This one is going to become 2, -4. And then that point is going to become 5, -4 like that. Okay, since you have that 2 in front of f of x, that's having the impact of multiplying all the y's by 2, right? So if you do this then, you just plot your points, then you'd have this point there, -5, 4. You would have -2, 4. You still have 0, 0. Then you have 2, -4. And then 5, -4. So your graph goes like that. And that's what I'd be looking for like on an exam, is that you've done those correctly. So that is a stretch. What we say on this is a vertical stretch by a factor of 2. Okay, that's real simple. Now some of these problems are going to have more than one transformation, but that's how you can begin. Okay, all right, if you look at the second one, okay, this one has 3 transformations. I went ahead and just wrote these out for you. So you have left 1, and remember you got to do this in the right order. So you got left 1, then you're going to multiply y by -2. Okay, and then finally you're going to take everything down. Okay, like that, down 3. Now you got to do it in this order that I have on your handout. You got to do left first, then multiply, then subtract 3. Okay, so what I would recommend you do, you don't have to write these points out. I just find when I teach this, students tend to do better on exams when they do this. So I'm just going to write these points out. That's -4, 0. That's what, -3, 2. Then I got -2, 2. And then 0, 0. Then I've got 3, -1. Then I got 4, 0 like that. Now all I'm looking for is the final product on this. Now you can do this all in your head if you want to. I'm just going to start by taking everything to the left 1. Okay, now I'm just going to do it this way, but again, you can bypass this. So that would be -5, 0. The next one would be -4, 2. -3, 2. -1, 0. 2, -1. And then 3, 0. So I just made all the x values go down 1. Okay, then I'm going to multiply all the y's by -2. Okay, so I'll do this kind of from here. So what I have is the x's are set, so they're not going to change. Okay, so what you want to do is just take the y values here and multiply them by -2. That'll cause it to stretch and reflect. So 0 times -2 is still 0. 2 times -2 is -4. 2 times -2 is -4 there. 0 times -2 is 0. -1 times -2 is +2. And then 0 times -2 is 0 like that. Okay? Now finally what I'll do is I'll just make everything go down 3. So that means those y values in that step, you just need to make them go down 3. Then you'll have what your points are. Okay, so it looks like the final thing you'll have is -5, -3, -4, -7, -3, -7, -1, -3, 2, -1, and then 3, -3 like that. Okay, so if you plot that last set of points, you should have it right. Okay, so again, just if you want to do it this way, you can, but if you want to try to do it in your head, You can do it that way too. I don't care. I just want all these points to be in the right place. So let's plot these points then. So it looks like we have -5, -3, -4, -7's kind of down here, I guess. And then -3, -7's there. And then -1, -3, 2, -1, and then 3, -3 like that. So you'd end up having a graph that kind of looks like that. So that's taking care of all the transformations. You can see it reflected. You can see it stretched. So it's, vertically it's been stretched. And then everything's been moved to the left 1 and then down 3. Okay? You guys see what I'm doing? Okay? So if you want to go through all that, you can. But if you want to try to just do those points in your head, you can do that. Because it's not that hard to do. But I usually recommend most students just do it that way until you're a little bit more comfortable with what you're doing. Okay? Okay, so I want to do just one last thing here. And I'm going to have you guys, this is almost the same graph. I guess it's the same graph, but what I did is I changed things around here a little bit. So let's just do kind of the same thing. I'll give you guys a little time to do this yourself, a couple of minutes. So let's do these points. Let's write down these points. -4, 0, -3, 2, -2, 2. Let's use 0, 0. Then we got 3, -1. And then finally we got 4, 0 like that. Okay? First thing you're going to do is you're going to go to the right 1. Remember, that's the first thing that you want to do. Okay? Then what you want to do with the 1/2, what are you going to do with the 1/2? What does that change? Changes the y value. So what you're going to do is you're going to multiply y by a half. Okay? And then the very last thing you're going to do is you're going to do the up 3. Okay? Go ahead and take a few minutes and see if you can do that, and then I'll put up what you should get here in just a minute. Okay? So go for it and make sure you can do this okay, because if you can do this fine and know the order that this goes through, it shouldn't be that difficult of a thing for you to learn how to do.